Okay, welcome to 5.1. The horizontal line test, if you just draw a horizontal line and it hits your graph more than once, so let's say we have a parabola, it's obviously going to hit it more than once, then it fails the horizontal line test and it's not a one-to-one function. So we can come back and visit these other things as we progress. Let's race through the first few graphs for the horizontal line test. All right, so the first thing here, obviously, A, B, and C, you have to say yes or no. Yes, it is one-to-one, or no, it's not. So we can draw horizontal lines on this one. So yes, that is a one-to-one function. This one, obviously not. It hits in two spots each time. So no, it's not a one-to-one function. But this one, yes, that's a one-to-one function. So you should know what the graph of this line looks like. So it goes through a 5 and has an up 2 and over 1. So that's going to be a yes, it is one-to-one. Now, x squared minus 5. Well, first of all, that's a parabola going down 5 units. So it would be something like this. But it fails the horizontal line test, so it's not a function. Okay, so most of these you should be able to do very quickly. The square root of x, if you remember, that looks like this. So yes, that's going to be a one-to-one function. You can draw a horizontal line, it's not going to hit more than once. Absolute value, we know that that's a v, and that fails the horizontal line test. So no, it's not one-to-one. So if you're unsure of certain things, as these get a little more complex, 4 minus x squared, we need to know what that looks like. Okay, so in general, if we had y equals the square root of 4 minus x squared, and we squared both sides, you would get y squared equals 4 minus x squared. And then you add x squared to the left side, and you'd say, hey, that's a circle with a radius 2. And you'd be wrong. Okay, so the square root changes all of this so that only certain things happen. So if you graph this function just like this, if we do an xy chart, real quickly, just do a few things here. We start at negative 2. At negative 2, 4 minus negative 2 squared, 4 minus 4 is 0. So at negative 2, you're at 0. All right? And let's go negative 1. Negative 1 squared is 1. 4 minus 1 is 3. Square root of 3 is 1.7. All right. About right there. And I went a little too far there. Anyway, let's just do it quickly. And 0. 4 minus 0, square root of 4 is 2. Okay. And if we go to positive 1, that's going to be the same thing as 1.7. All right, so we're up there again, and then positive 2, we're down here. So this is going like this. All right, now what if we did 3? 3 squared is 9. You get the square root of 9. 4 minus 9 is negative 5. You can't take the square root of negative 5, so there's nothing left here. What about, and that was positive 3. Same thing with negative 3. So this is the picture of that graph. So either way, at this point, we know it fails. And it failed up here, but it wasn't a circle. All right, now, from yesterday's lesson, 1 over x, we know that the y-axis, or the x-axis, is a horizontal line. The vertical line is when x equals 0, so it's the y-axis for vertical stuff. And when x is negative 1, you're at negative 1. So we know that this went like this. All right, well, that still is one-to-one, yes. So we should know the shapes of these graphs before we start, and you should be able to go through the first half of the problems very quickly. If not, then you take your time to learn them. Okay, so to just do a simple answer of what's happening in the inverse, it's always opposite of what you think. If you have x and y, then the inverse should be y and x in opposite positions. Okay, so let's talk about domain. The domain of the normal function here, f of x, okay, the domain is going to be from negative infinity to negative 2, okay, union with negative 2 to positive infinity. And then the range of our f of x is going to be, excuse me, from negative infinity to 4, union with 4 to positive infinity. Now, your inverse switches all that. So the inverse of f of x is going to be the range from f of x, okay, the range of f of x. So it just switches everything. In the inverse of f of x, the domain, so we're going to say the domain is the range, and the range of the inverse is going to be the domain of f of x. So you flip those. I know it sounds kind of strange. So here's what happens. It's asking, let's just do part A here. It wants, as x approaches -4, okay, the inverse does what? So we're looking at the inverse, and if we're doing the x values, what's happening on the range? Okay, it's approaching the 4, right? Except what you're looking at is it's wanting you to look at that and be like, when x is -4, then you get -1, because what happens? On the inverse, it switches your x and y. So you have to think of it backwards like that. Now, I'm not going to be pushing this because after the homework assignment, then you might be able to come back and understand what this is. So that's just a simple little example that's very hard to understand. So let's move on from here. If you wanted to know, these are the answers for those, and you can kind of contemplate what it's saying. Okay, let's get back into doing hey, how do I do the problem so I can get it done? All right, so use the theorem on inverse functions to prove that f and g are inverse functions of each other, and sketch the graphs. Okay, first of all, how do you do this? All you have to do is put f of g of x in and see what you get. So let's do that. So f of x is this, so 3 times g of x, x plus 2 over 3, minus 2. Let's solve that and see what we get. So that goes away, and you get x plus 2 minus 2, which is x. All right, well, let's do g of f of x and see what we get. So this is g of x, so x is going to be 3x plus 2, or minus 2, that's your f of x, plus the 2 over 3. All right, so the minus 2 plus 2 is gone. You get 3x over 3, and you get x. If you get x's for both, and you do have to do both, then they are inverses of each other. So let's just take the f of x function and show you. F of x equals 3x minus 2. So y equals 3x minus 2. So what you're supposed to do is switch x and y, and then solve for y. So x plus 2 equals 3y. Divide off the 3, and look at that. Y is x plus 2 over 3, which is the g of x function. And then you'd have to do it the other way as well to prove it. So this is probably the fastest way to do it. Just plug one into the other and vice versa to show that you get x. And here's the important part. You have to get x when you do that. All right, now we're supposed to graph both of these. So I'm going to move this up. And we're going to do 3x minus 2. So 3x minus 2 goes through at -2, goes up 3 and over 1. Up 3 and over 1. Or down 3 and over 1. All right, so there is f of x. All right. Now, what was g of x? G of x was x plus 2 over 3. So x plus 2 over 3. All right. So really what that is 1/3 x. If you put the 3 underneath each thing, it's still a straight line. All right. So this is actually going to be the inverse of x. We've already shown that it's the inverse of each other. So that's going to go through at 2/3. And the slope is up 1 and over 3. 1, 2, 3. Up 1 and over 3. Okay, so that is what g of x looks like. Okay, so those are your graphs and how to find the inverse. Let's move on. All right, 21. Use the theorem. We're doing the same thing here. Okay, so let's just do it real quick. F of g of x. Okay, let's plug it in. So wherever x is in this function, we got to plug this in, the g of x in. So negative square root of 3 minus x. Notice it says that x has to be greater than 0. There's a purpose for that. Plus 3. All right, so we square that, we get negative 3 minus x. It's a group. Don't forget you're going to have to distribute the 3. So negative 3 plus x plus 3. And the 3's cancel out, leaving just x. All right, Now let's do g of f of x. So we're putting f of x in for all the x's over here. Now this is for all the x values less than 3. So when we graph it, we need to pay attention to that. As of right now, we get 3 minus a negative x squared plus 3. So what do we get here? Inside, we get 3 plus x squared minus 3. The 3, and I distributed the negative, by the way. So we have 3 and a minus 3. Those cancel out, leaving the square root of x squared, which is x. All right, so we proved that they're inverses of each other. Now let's graph them. All right, so we'll do f of x in black. Excuse me. So this is a parabola opening down, and it shifted up 3 units. Okay, so let's put this in the right spot here. At least the origin at a nice neat point. So up 3, and it opens down. Boom. All right, now it says for x greater than or equal to 0, so we need to erase this part. Okay, so it's just greater than or equal to 0. Make sure we get the equal part in there. And now let's do g of x in blue here. It's the square root function. So let's look at that and change it to the negative x plus 3. Okay, so the square root function, this is shifting to the left 3, 1, 2, 3, and it would go like this, except the negative on this reflects it horizontally. So we're reflecting this back over to this position and going like that. So that's what it would look like. So those are your two functions, and they're inverses of each other. Think about it. If you tilted your iPad or whatever down to the left 90 degrees, you would have the original x plus 3, square root of x plus 3, and then you put a negative in front of the x, it would reflect it the other way. So that's what you get. All right, let's go ahead and move on. 23. Determine the domain and range of the inverse for the given function without actually finding the inverse. Okay, first find the domain and range. All right, so that's what it's saying. So if you remember the domain, let's do it in black. Domain of f of x is going to be, it can't be 1, but it can be everything else. All right, so negative infinity to 1, because 1 makes your denominator 0, union with 1 to positive infinity. All right, well, what's the range of f of x? Okay, the range of f of x, what's happening in this? Remember, you have a horizontal asymptote at 0. So the x-axis is the horizontal asymptote. So it's all real numbers except for y equals 0. So the range is negative infinity to 0, union with 0 to positive infinity. Okay. Now, so the domain of the inverse should be the same thing as we did as the range. So the range of f of x should be this part right here, just that bottom piece. It says find the domain of the range. Okay, so the range then of the inverse is going to be the domain of f of x. That's what it should be. And we talked about that on number 17. So like I said, you're just switching your x's and y's around for your ranges and your domains. All right, same thing here. What is the domain of f of x? All right, so x can't be positive 8/3. So you set your denominator. Your denominator can't be 0, right? So you set that equal to 0, add 8, and divide by 3. So from negative infinity to 8/3, union with 8/3 to positive infinity. And the range of f of x, where's the horizontal asymptote? At y equals 4/3. So going up on the y-axis from negative infinity to 4/3, it can't be 4/3, and then from 4/3 all the way up to positive infinity. So if you're just not sure of all this stuff, you have to graph them. You're supposed to be good at graphing them at this point. So you're looking for asymptotes and stuff. So what is the domain of the inverse? Well, that's going to be the range of your normal function. And the range of the inverse is going to be the domain of the f of x. Doesn't mean much unless you see a graph, but It's just trying to help you get further understanding of what it is you're finding. And right now you're just scraping by to try to get the right answer. So let's keep chugging along and try to get better. Okay, so this is really what I want out of this whole section, not just the domain range, but how do we find the inverses? Okay, I want you to be able to find the inverse, and I want you to be able to prove that something is the inverse of something else. So the inverse, y equals 3x plus 5, switch x and y, and then solve for y. So x minus 5 equals 3y, and divide off the 3. So x minus 5 over 3. So that would be your inverse. So the inverse, of x is x minus 5 over 3. Okay. I haven't been showing me answers to verify much. I can keep doing that here if I can remember to do it. Find the inverse function of f. Okay, again. Now you do it, pause it, and try it on your own. So I'm switching these. And you may have a different method, and that's totally fine. So now I need to solve for y. So I got to get out of the denominator. So I'm going to multiply by my denominator. Okay, so I get x times 2y minus 5 equals 3. And now I got to get y by itself, which means I really need to distribute. So I can remove that 1x here. So I'm going to add 5x to the right. And I get 2xy equals 5x plus 3. And to get y by itself, I'm going to divide by 2x. So I divide off the 2x. So my inverse is going to be 5x plus 3 over 2x. That would be the correct answer. Let's check the answers. And there you have what I have. So it works. Looks good. Let's keep going. Okay, again, try this on your own, please. And then pause it, try it on your own, and then try to figure it out, see if you got the right answer. All right. All right, so let's write it out. Switch everything around. So x equals 3y plus 2 and 2y minus 5. Okay, now there's a problem. How do you do this when you have y in the numerator and denominator? You got to get them together. Well, first of all, you still have to get the denominator y out. So we multiply both sides by that. And we're going to distribute the x through that. Okay, so that's 2xy minus 5x. And that equals 3y plus 2. So let's now get our y terms on the same side. So we're going to subtract 2xy to the right and also subtract 2 to the left here. Do two things at once. So we get a minus 5x minus 2 equals 3y minus 2xy. And now we can factor out a y from the right to get it by itself, and we get 3 minus 2x inside. Okay. So now what does y equal? We're going to divide off that parentheses. Okay, and we get negative 5x minus 2 equals, or over 3 minus 2x equals y. So our inverse should be negative 5x minus 2 all over 3 minus 2x. Now, they don't like to leave it as a negative leading. So what we're going to do, I'm fine with this at this point, but I want to show you what the book might do. Actually, let's just look to see what they do, and I'll explain if it's different. Okay, so notice they're very similar, but all the negatives are different. So I just want to show you, if I factor out a negative 1 on the top, I get 5x plus 2. If I factor out a negative 1 on the bottom, it changes all those answers, or those signs. So it becomes a positive 2x and a negative 3. And a negative over a negative is a positive. And now you have what the book has. So they don't like leading terms negative. So just an FYI as you're looking at that, if all of your signs, and I mean all of your signs, are opposite signs, then that just means you can factor out a negative on the top and the bottom. It goes away. All right, find the inverse function of this. All right, so y equals 2 minus 3x squared We're going to focus on that just to make sure we understand something. All right, so switch x and y and solve for y. Don't forget the negative. So now we're going to divide by -3. And it's x minus 2 over a -3 equals y squared. And we're going to take the square root of both sides. And so that is the square root of x minus 2 over -3 equals y. And notice the book took a negative out in front and changed all the different signs. Okay, this is totally okay to leave it like this, and that's what happens when it says x has to be less than or equal to 0 there. Because if x is less than or equal to 0, in the numerator here you're going to get a negative, and then you got a negative on the top. So that means inside is going to be positive as long as x is negative. All right, this is all I need. Okay, let's just keep going. Find the inverse function again. All right, so you guys stop and try it. We're getting there. Yeah, all right, now we're getting a little faster. Okay, same thing. Again, stop it, try it on your own, and then come back to this. So I'm going to switch everything right away. X equals the square root of 3 minus y. Square both sides. X squared equals 3 minus y. Subtract 3. Don't forget the negative on the y. And now multiply everything by -1. So f, the inverse of x, is going to be a 3 minus x squared. If you do the negative on everything, it changes all the signs. All right, again, it's okay to say negative x squared plus 3. And they give you a parameter there. X has to be greater than or equal to 0. Because if you put negatives in, you're going to have negatives under the radical when you eventually do all of that stuff, okay? So let's go ahead and keep moving. All right, you do it and come back and see if you got it right. All right, so x minus 1, cubed root of y. So we cube all sides, and we get y equals whatever x minus 1 cubed is. So figure it out. So we get x minus 1 times x minus 1 times x minus 1. Go ahead and do that. So the first two are going to be x squared minus 2x plus 1 times the x minus 1. So x cubed minus x squared minus 2x squared plus 2x plus x minus 1 equals y. So the inverse is equal to x cubed minus 3x squared plus 3x minus 1. And of course the book leaves it in factored form for some dumb reason. Okay, let's keep going. All right, so we'll leave things in factored form from here on out since the book is doing that. Switch them and figure it out, pause this, and then come back and see if you did it right. So we have x equals y to the 5th minus 6 cubed. So now we got to take the cubed root of both sides, and we get the cubed root of x equals y to the 5th minus 6. So we're going to add 6 to both sides, and we get the cubed root of x plus 6 equals y to the 5th. And now we're going to take the 5th root of both sides. All right, there's no way the book's going to leave it like this. We'll go ahead and check and then come back and show you what they did to change it, okay? Okay, absolutely ridiculous. I cannot believe the book left it like this. All right, well, it's pretty simple. Just change x and y and solve for y. And wherever that's at, you're done. It's funny they changed all the negatives on that other problem, but they're not changing the radicals on this. Okay, let's just keep going. We're getting there, only a few more problems, all right? So switch everything and then come back and see if you did it right. Looks like an easy problem. Let's find out if it is. All right, so x equals y, I switched them, and I solved for y, which it already is solved. So the inverse is going to be x, okay? Which, that's what you're getting. Notice you have it's equal to x on both of them. All right, so that was an easy one. We'll go from there. 45. Do the same thing. Pause this. It's important to understand what that is, but again, I just want you to find the inverse. So let's just find the inverse, and we'll take a look at what the book says and go from there. So pause it and come back. All right, x equals negative 9 minus y squared. Now, that's negative, so we're going to drop that, move it over, multiply both sides by negative 1, excuse me. Now, square both sides, and if I square both sides, notice what happens. I'm squaring that negative. That becomes x squared. Now, x squared minus 9 equals negative y squared. Don't drop the minus. Multiply everything by negative 1, and then take the square root. So we have, if we just did the simple stuff, this is what you get. Negative x squared plus 9. And now, this comes into play. If x is between negative 3 and 0, let's just say negative 1. Watch what happens here. Negative 1 squared is 1, but you have a negative in front, so that's going to be negative 1 plus 9, or the square root of 8, which totally works, right? Okay. So what about outside of those parameters? Outside of them, it's not going to work, because when you square a value, you're going to get a bigger positive than the 9. So like 5 squared is 25, except you have that negative in front. And a negative 25 plus 9 is a negative. You can't take the square root of a negative. So that's why that parameter is there. So the answer is still negative x squared plus 9, the square root of that. Now it has a little comma in the answer there, but what goes there is that part, just to remind everybody. Notice they switched the 9 and the x squared around, took out a negative. Because it has to be negative. All right, moving on. Okay, so here's a crazy one. We have where our variables have different exponents. So x equals y squared minus 6y. That's how we start. And at this point, you can't get y by itself. If you factor out a y, you still got a y in the parentheses. So if we complete the square, if you remember, you'll eventually end up with something like this. And then you can take the square root and you'll have 1y. So the completing the square gives us a chance to end up with one value. So we're going to go ahead and complete the square here. I wouldn't expect you to remember that, but now you can see it. If your variables have different exponents, it's probably best that you try to look into something like this. So how do we complete the square? You take half of b, half of 6 is 3, square it, and add it to both sides. So this is the basic completing the square from Algebra 1. So what happens here? Well, you still have x plus 9 on the left, but on the right, this is factored into what? Factored into y minus, and then b over 2 goes here. And if you just want to, just factor the trinomial. It's y minus 3 times y minus 3. Okay, so that's y minus 3 squared. And now we have just one variable. How do we get it out of that parentheses? By taking the square root of both sides. So we have the square root of x plus 9 equals y minus 3. Add 3 to it. So the square root of x plus 9 plus 3 on the outside equals your inverse, or y. Okay? All right, so let's see what the answer is. Okay, so you can see that they just put the 3 out in front just so that it didn't look like the square root sign was over the 3. All right, last problem. Okay, h of x is 4 minus x. Okay. Use h, the table, and the graph to evaluate the expression. Okay, so the inverse of 2. Okay, so the inverse of 2. Okay, So what do we get when we do the inverse of the inverse? I want to take a different approach of this, and hopefully you can try to see this. This is actually a very easy problem, but it makes no sense to you if you don't grasp what's going on. Notice this says g of x, and we've been given the equation for h of x, and we have the information for f of x. Okay, so let's just take a look quickly at f of x. If we plot those points, 2, -1, 3, 0, 4, 1, 5, 2, and 6, 3, we notice that's a straight line, right? And it's going to go through the y-axis at -3. So y equals something x minus 3. Well, what's the slope? It's up 1 over 1, up 1 over 1, all right? So f of x is x minus 3. Now, we don't know g of x, we just have those numbers, right? Okay, so let's look at the domain of f of x. The domain is going to be all real numbers. The range is going to be all real numbers. Okay, and it doesn't look like g of x is going to be that way. All right, so what about h of x? All right, h of x is 4 minus x. All right, so let's just plug these down here. H of x is 4 minus x. Okay, so, and that's actually -x plus 4. And we'll do h of x in blue here on this graph. So it goes through at 4, 1, 2, 3, 4. It goes down 1 and over 1. Okay, so here we have the graph of h of x. And then g of x has these points on here. I'll do those in red. -1, 1, 2, 3, and 3, 5. Okay, so that's your g of x. This is f of x. And this is h of x. All right, so now what I'm going to do is I'm going to put g of x right here. And the question is, and I'll put h of x here as well. When x, we're going to look at the x values here. When x is 2 on g of x, we are at 3. Okay? And on h of x, when x is 2, let's use yellow lines over here. Here's x is 2. On h of x, we're at 2. On g of x, we're at 3. Excuse me. On h of x is 2. Yeah. F of x, you're at -1, which is what it says right there. All right. Now, when x is 3, the next line over, g of x is going to be 5. And h of x, looking at our graph on the right, is going to be at 1. All right. And when x is 4, we go one line over. One line over g of x, we don't know. Okay. But h of x, we do. H of x is going to be 1. Excuse me, at 0. It's going to be 0. When f is 4, I was looking at the wrong graph. All right. H of x, I put it in the wrong spot. H of x is 0. We don't know g. So I'm just going to put these little slashes in here. We don't know those values for g of x. But h of x when x is 5, again, look over here, 5. H of x is down here. H of x is going to be -1. And when x is 6, h of x is going to be -2. Okay? Now remember what I said, everything flip-flops if they're inverses of each other. Okay? So now we need to know the inverses of these things. All right, so you have a visual here, and so let's just talk about the easiness of this. You're just flipping everything around. It's just because they started with these inverses and these complex situations that it makes it look like it's difficult. So I showed you the graphs and stuff. You do not need to graph them. Really what we need is an understanding of this up here. So let's look at the inverse of 2. So f of x, it's not saying when x is 2. It's saying when y is 2. So highlight it in yellow here, circle the 2. When y is 2, that means the inverse of 2 is 5. You do it backwards. Remember, you flip-flop your x and your y. So the inverse of 2, usually you're talking about when x is 2, but now you're talking about when y is 2. So when y is 2, x is 5. So now we have the inverse of 5. But now we're looking at on G. So again, flip-flop this. It's not when the y value, or the x value is 5, it's when the y value is 5 in the G area. So remember, these f of x functions, g of x, h of x, whatever letter of x, those represent the y values. So when you're talking about the inverse of a number, that's the y value. So when g of x, the y value is 5, what is the x value? It's 3. So part A, the answer should be 3. All right, let's do another one. Number B, letter B, h of 3. Now, it's not the inverse of 3. Now it's saying h of 3. Okay, so what does this say? The inverse of h of 3. The inverse of g of h of x. All right, it's not the inverse of h. So now, what is the h value when x is 3? When x is 3, let me erase some of the stuff up here. And, oh, rats. Let's just back that up a little bit. I'll just write them in as we do. When x is 3, what is the h function? That's 1. So now what is the inverse of 1 on the g function? Meaning not x. When y is 1, okay? When y is 1, now we got to plug all those back in. But we can look at these values down here. When y is 1 on the g function, that's right here, what do you get? You get negative 1. Okay, now c, we got 3 things to do. So the first thing is, on the g function, that's asking when y is 3. Typically, we think that's x. But when y is 3, look at the graph. When y is 3 on g, we get 2. All right, so now we have the inverse of f of 2. It's not the inverse of f. The inverse of g of 3 was 2. Now we're taking f of 2. So now, that's a normal function, f of 2. When x is 2, go up to 2. X is 2 right here. So what's the f function when x is 2? That would be negative 1. So now what is h of negative 1? Not h of negative 1, the inverse of negative 1, meaning when y is negative 1 on the h function, which is right there. So when y is negative 1, we get 5 for our answer. All right, so these were complex to hit you right off the bat. All right, so let's see what the book says. And there are the answers down here at the bottom. You just flip-flop everything. Hopefully we can choose some easier ones to do. These were just complex right off the bat. All right, that's the end of it. Good job.